Alrighty, good evening, everyone. This is meteorologist Timmy Albertson here with you guys for tonight's weather chat. We're going to take a look at that area of low pressure that's now working its way through the central part of the U.S. With that in mind, before we go any further on that, just want to make sure I update you guys in case you didn't see last night's weather chat that AWSC is now providing personalized forecasts for those who so desire them. Again, basically, you want to have your own meteorologist. Again, it's more than just me at AWSC. I'm not even the one in charge. But basically, we got a lot of meteorologists. All of us are degreed. All of us have experience forecasting and been doing this for quite a while. We got some people who are with who worked with the National Weather Service. You got me, who was in broadcasting for a long time, and we have again a lot of great people on the staff. So depending upon where you live, you get a different meteorologist, obviously. If you live in Wisconsin or Minnesota, I'll be your forecaster, as well as a few others that might be helping out too. So with that in mind, where can you go to find out more? That's simple. Head on over to our website, americasweathersc.com. It stands for America's Weather Streaming Channel. But streaming channel, too much to type out. So americasweathersc.com is a little bit easier to remember. Alrighty, and for those of you who do decide that you want it, use the promo code STARTER23 and you'll get a little bit of a discount. I like saving money. Of course, I don't make much money, but you get the idea. All right, everyone, with that in mind, want to talk about some weather? I know I do. Let's go ahead and flip on over to our good friend, the surface map, and let's take a look. There is our center of low pressure. We were talking about it in depth yesterday. It was, still trying to get itself organized in eastern Colorado. The whole upper level system is caught up with this guy now, and look at that. That's a pretty decent sized low pressure. Now, we talked about how, at the surface, the average pressure, the average sea level pressure around the world is about 10, 12, 10, 13 millibars, okay? This one's about 991, so it's low, all right? It's lower than the average. And, for a mid-latitude low pressure system, that's a pretty good intensity. Now, obviously, we could see them get a lot stronger than that. They don't typically have pressures as low as hurricanes, but some of these guys can sometimes get pretty strong. It's actually kind of impressive sometimes, some of the low pressure values they can reach here. But we're early in the season, so again, this is probably not going to be the strongest one that we're going to be seeing. Again, we still have, another 5 months of this setup at least. So hopefully we'll be seeing some more strong low pressures here. But this is the guy that we talked about yesterday that was helping to produce some snow out across the mountains along with the whole upper level system. Check this out, by the way, when this chart came out a few hours ago. Look at this observation right here, 19 degrees. Again, we're looking at Colorado here. Obviously, we're in the mountains, so it's not exactly representative of the overall surface in that area, but you get the idea. 19 degrees with a little bit of snow there and a wind coming in from the northwest at 35 knots. Yeah, so in weather, we use millibars for pressure. We talked about that yesterday. For those of you who might have a barometer at home, it might be in inches of mercury. In weather, we like to use millibars, and we like to mix it down to sea level because the pressure can change based on your elevation. So we use a formula that helps us to, even if you're in a high elevation, what you see here is sea level pressure. I know, right? A lot of words there for you, but again, that just takes the altitude out of the equation so we can see areas of low pressure better. Otherwise, the Rocky Mountains would always be an area of low pressure, and it would kind of obscure things. So we like to mix it down to sea level. Anyways, I don't know where I was going with that one. Knots. So in weather on these maps, we like to use knots. I don't. I don't know why we still use knots. As a matter of fact, I don't know why. Because all of our equations, that we use in meteorology, and we have a lot of equations. I mean, believe me, we got equations that you don't even want to see. They all use meters per second. That's the SI unit that we use. But for some odd reason in weather, we like to complicate it, and we put it into knots, which is a unit that, unless you're a boat or an airplane, you don't use. And I don't know why boats and airplanes still use that because no one else uses it. I think their idea was that they wanted a unified scale, obviously, when they were deciding this years ago. I don't know why they didn't just pick metric. but we pick knots. So 1 knot is equal to about 1.15 miles per hour. So 35 knots, about 40-mile-an-hour sustained winds. That's pretty breezy out there. If a temperature of about 19 degrees, it'd be interesting to know what that wind chill is. There's an equation for the wind chill too. I just don't have it up. So I didn't think that part ahead. Guess should have done that. But here's what's really cool. Take a look at this. 19 degrees here. Go down the mountains, 56 degrees. Boy, that is a heck of a gradient there. And again, that's why we kind of had that dry line earlier on. Yesterday, we were taking a look at the weather map. The dry line, again, we get that colder air and it descends down the mountains. It warms as it does so. And again, a lot of times it's drier. So that created that dry line. Of course, the dry line, I don't think here, let's look a little bit down to the south. It's still there across parts of western Texas. And take a look here. You know, we talk about the dry line. Again, it's a hot, dry air mass, courtesy of the cold air mass over the mountains. When it descends, it warms, also loses its moisture a bit. And so we get what's known as a dry line. And it kind of acts as a cold, not as a cold front, but it kind of acts as a frontal boundary. And in severe weather, especially in the spring in the plains, the dry line is often the initiator when it comes to producing those big, strong storms. Because the hot, dry air behind it is a lot denser than the not quite as hot, but way moisture air from the Gulf of Mexico that happens to be right out in front of it there. So again, it's a change of air masses, so it is kind of technically a front. But, you know, unlike, you know, a cold front, when this thing passes through, it gets really hot, but it also gets really dry. Take a look at the dew points. They're in the, you know, upper 50s out across here. Let's see here. Well, San Antonio's back over here. I can't remember what they call this area. Oh man, I love my geography, but I always forget what they call this area. It's like a plateau. Anyways, what I'm trying to say is these are some, you know, decent dew points. Okay, they're in the 60s, 50s, so it's kind of a somewhat of a moist air mass. But look behind here, dew points sitting in the 30s, and I've seen some, especially in the spring. Some of these dry lines, when they come through, dew points single digits with temperatures, you know, literally we're talking 90, sometimes even over 100 degrees. So it's a very, very dry air mass. This one, not as extreme as that, but again, they are always very fun to watch. And dry lines are kind of interesting too, in that they seem to kind of jump, if that makes any sense. It's really kind of weird. I mean, obviously they move, but they seem to kind of like to jump a little bit. With that in mind, moving rapidly along off of that, that is your dry line. Obviously, it's not really playing a role right now in what we're talking about. So let's go back up. Sorry, West Texas. Let's go back up to the central part of the plains here and talk about our good friend here, the low pressure. And this is actually a really good example to use as to the structure of a low pressure, at least at the surface, what we tend to see. Now, obviously, in weather, not everything is the same. As a matter of fact, there really isn't anything, you know, you throw out the term textbook example, and I've used that occasionally, but honestly, good luck trying to find, you know, a textbook example, you know, in real life, and that's just because there's so many factors that go into everything here. But this is actually a really good low pressure to kind of describe what's happening here around an area of low pressure, at least at the surface. So we'll take a look at the upper levels here in just a little bit, but basically, what we had was a little bit of a temperature gradient. That was courtesy of that colder air kind of rushing down. We had a little bit of a frontal boundary that was stalled out. I believe it would have been, back it up here, over the weekend again, we had this little bit of a frontal boundary here. Something needed to kind of trip it to get it, you know, the air to start moving. That was that upper level low making its way off the Pacific coast. And that kind of, you know, took our little low pressure down here and developed it into this big area of low pressure that we have now. So now we got an area of low pressure, which if we wanted to go based off, you know, the cyclone models that we have, cyclone area of low pressure, and whether we have different names for everything too, not to be confused with a cyclone that you'd see down in the Indian Ocean or Australia, which is the same as a hurricane and a typhoon. Obviously, it's an area of low pressure, but those are tropical. This cyclone that we're talking about is a mid-latitude low. All right, I don't want to lose you all here yet. So this is actually really cool. So basically what we got going on here is we got an area of low pressure that is trying to lift air. It's also trying to even everything out. But obviously the Earth rotates, the heating's uneven, So low pressures typically fight a losing battle in most cases, and their attempts to, even everything out often, don't end up working in weather. So we got an area of low pressure that's lifting warm, moist air. That's what's feeding this low pressure, okay? At the same time, we got this cooler air rushing in behind it here, area of higher pressure, trying to, basically even things out with the low pressure. Get low pressure, there's an area of low pressure, there's got to be an area of higher pressure. That's the atmosphere's way of trying to even everything out. So here's what we got going on at the surface. We got basically a pressure gradient force, which is air likes to flow from areas of higher pressure to lower pressure. But there's a few other factors that go into it, and one of the driving ones, because the Earth is round and it also rotates, something known as the Coriolis effect, which is, believe it or not an actual force. Coriolis force, the Coriolis effect. Basically, it's not an actual thing. It's really trippy in weather. You hear that term, and again, it's in our equations and everything. But it's actually not it's not an actual force. It's a product of the fact that the Earth rotates. So it's kind of hard to explain, but it's not like gravity, which is a force, or electromagnetism, or that kind of thing. It's more of a weird compensation thing that you have to do based on the reference and everything. So anyways, long story short, the wind ends up not being able to go straight. It gets kind of turned a little bit, and it creates, kind of that, let's see here. It basically kind of prevents the air in a weird way from being, perfectly unified in the way it rotates around in low pressure. Yeah, I'm trying to explain a scientific thing without over-scientifically it. Anyways, long story short, area of low pressure, air is converging, okay? It's all going towards it. All right, again, that low pressure wants to, move that air and everything. It's an area of low pressure, so areas of higher pressure around it, that air is rushing inwards here. Again, the Coriolis effect kind of turns it a little bit, and we also have friction that plays a role in it too. And friction will actually kind of angle those winds a little bit inwards too, so it gets kind of weird. So again, there's a lot of things that are going on here with this low pressure, but basically, long story short of it is that it creates a counterclockwise flow, at least in the northern hemisphere. It's different from the southern hemisphere, but it creates a counterclockwise flow. All right, what does that mean? It means if the wind starts up here, if you can see my cursor right above the low pressure there, I'll make sure I move it so y'all can see it. There you go. All right, the air is going like this. All right, it's going counterclockwise. So northwesterly winds over here, southwesterly winds over here, easterly winds, you get the idea. So we have this area of high pressure up towards the north that's creating a little bit of a pressure gradient here. So this is where the winds are the strongest right now, and also across the mountains where there's some other factors going into that, such as, there's a mountain there, so that air's got to rush, got less room to work with. But pretty much, here's our warm sector right down here, winds coming in from the southwest. It's also drawing up air from the Gulf of Mexico, which is why it's so high in its moisture. Then we got this, colder air mass that, again, is a little bit drier, at least in some areas here. And again, that cold front is pushing, its way in. So this low pressure is going to keep trying to lift as much air as it can until the air column itself cannot support any more air because there's not enough divergence in the upper levels. Now, there's a few other things that play into fact here, but basically we have this upper level low that is right now centered over in Nebraska. I know I explained it yesterday, so if you want to know more about exactly what this map is showing, then make sure you tune into that. But we talked about how at the end of these little jet streaks generally is an area of upper level divergence. But again, things get a bit trippy because friction isn't as much. So, it's slightly different kind of things going on in the upper levels just because of the lack of friction. So there's not as much upper level divergence in this type of a setup here. So eventually that area of low pressure is going to start to struggle a little bit because it can't keep pushing air. There's already air in its way and it doesn't really have anywhere to go. So that will start to kind of spell the end of the low pressure. Also, another thing happens, and that is that the cold front will begin to overrun the warm front. So this area of low pressure right now is pretty much what we call a mature low pressure. It hasn't quite reached the occlusion stage. And what is the occlusion stage? It's when that cold front Cold front will move faster than the warm front, so eventually that cold front will catch up to that warm front, and it'll begin to cut off the warm inflow, and the low pressure suddenly finds itself lifting heavier air, colder air, denser air. That's a lot trickier for it to work with. However, with strong systems like this, even though that might spell the end for one particular area of low pressure, with the way this system is set up, is it's not the end of the overall system. And a lot of times what we'll see in what is known as the triple point, which is where that cold front meets up with that warm front, we'll see a new area of low pressure developing, sometimes just a little bit later on. And that's actually what's likely going to be happening here. So this is going into tomorrow afternoon. There's our area of low pressure. You can see that colder air has now cut off the warm air inflow. Watch what happens as we move our way into tomorrow evening. Likely going to see a new area of low pressure developing. And folks, the system is just going to kind of continue on. So we're expecting to be seeing a lot of rain, especially on the northern edge of the system. And as we go into the weekend, it's looking like it'll be over the Great Lakes and over the Mid-Atlantic and Northeast, probably making it for somewhat of a wet football forecast here. So I just kind of wanted to show that. I know, probably wasn't the best explanation, but it's important that you at least hear it now. So when we get, more areas of low pressure develop, you won't be hearing everything for the first time. So it's all right if you don't understand it. Again, there's a lot of things that are going on here with these areas of low pressure. It's not just cold front, warm front. There's a reason for the warm front. There's a reason for the cold front. This whole thing is just trying to move air around. It's trying to even things out. But again, like I say, low pressures, because of other reasons, they normally don't succeed in that, and that's why we have them. So very fascinating, nonetheless, to kind of keep an eye on there. So let's go ahead and flip on over to the radar, folks. We talked about yesterday about the possibility for there being some severe storms out ahead of that cold front right near that center of low pressure over in Nebraska and parts of Kansas, and that actually did end up happening today. They did actually have some severe thunderstorms out there and a few reports of a couple of tornadoes. Now, it appears, at least from some of those reports, they weren't big tornadoes, but there was probably at least a couple of them. So we weren't expecting this was going to be a big severe weather outbreak, and it wasn't. It was, just for a few hours, there were some decent storms that managed to rotate a little bit and, again, produce not only a couple of tornadoes, but also some decent-sized hail, which, of course, is common across the Great Plains. But now that, of course, it's October, folks, the sun is not up as long as it is in October. So the sun began to set, and obviously this being in Central Time Zone where it's now about 7:20, the sun is not up, and we lose that diurnal heating, that daytime heating, and a lot of those severe storms have since kind of collapsed. There was tornado watch that was up earlier on. It has since expired. It expired just a few minutes ago. And so now, while there might still be a few thunderstorms, we're not really expecting much in the severe weather probability. With that in mind, folks, I think we have a special guest here that wants to join in really quickly. We seem to have our good friend Velvet, the weather cat. Come here, Velvet. You want to say hi to everyone? Oh, she's loud. Velvet, come here, girl. No, now you want to be shy. Come over here. All right, Velvet. Now, people in Ohio might know who you are from our time on TV, but everyone, this is Velvet, the weather cat. She is good at helping to explain things. Velvet has been with Velvet. How long have you and I been around? How long have you and I have been a pair now? We've been what now? Going on 8 years. She's a rescue kitty. I got her when she was 2. No one wanted her because she didn't like being held. Yeah, you still don't like being held. She's a nice cat though. Anyways, Velvet, yes, we'll get to you in just a little bit. Anyways, there you go. We also have another companion here too that you haven't met yet, but at some point you will. She is the weather raccoon. Anyways, there you go, folks. That is tonight's weather chat. I think we've gone long enough with this. Pretty cool with that area of low pressure. Like I said, folks, if you didn't, don't worry if you didn't understand a lot of what I explained to you. We'll go through it more. Of course, right now it being kind of in the evening and some other things, this weather chat not quite. But I encourage you to watch yesterday's, kind of explain those upper levels a little bit and kind of the development of, how these low pressures like to develop a little bit here. We have our example that we talked about, just mainly the airflow around it, what's going on. It's that area of high pressure. Air likes to flow from high pressures to lower pressures. All right, it's pretty simple, but again, Coriolis effect, a few other things, including friction, will kind of steer it off just a little bit there, and that's what gives it that nice counterclockwise flow with a low pressure, and that's what we're seeing now. So now we're just going to wait to see when exactly is that cold front going to catch up with that warm front, begin the occlusion process. But again, folks, this whole system is pretty healthy, and it's likely going to continue on. So even though the center of low pressure will probably change maybe once or twice as it tracks its way through the U.S., the overall system's still going to be there. So it'll be pretty cool, pretty fun to watch. Again, rain showers going to be likely across Wisconsin, Minnesota, the Dakotas as we go through the overnight tonight and even into the day tomorrow as we go into tomorrow evening and then heading into the weekend. It'll be Great Lakes, Mid-Atlantic, and Northeast. We'll be seeing some rain showers there. Looks like it could be kind of wet for some of those football games. I'll be watching the Penn State game. They're home this week, and it looks like it'll probably be raining during that time, or there'll at least be some rain showers around. So that'd be pretty fun to watch too. Now you get football and you get weather. I've been to a football game when it's raining before. It's fun. Anyways, alrighty, everyone. With that in mind, I hope y'all have a good rest of your evening. Thanks for sticking with me on this one. We'll back tomorrow evening. We'll take a look at everything else. And yeah, who knows? Keep it on our fun little area of low pressure. And like I said, hopefully we'll be seeing a lot more of these as we go through the next couple of months. After all, air temperature contrast is greatest in the fall and winter and early spring. A lot of colder air up to the north, warmer air down to the south. Beautiful breeding ground for low pressures. All right, everyone, take care. Hope you all have a good rest of your evening. We'll see you back here tomorrow evening. Maybe Velvet will join us again. Who knows? Take care, everyone.